Okay, till now we have seen how to what are the actually data link protocols which are uh, used for framing, error reduction, and uh, as well as flow control. How to control if the medium is single medium and the only sender one user and one receiver would be there. But if you have the in real world we have multiple user will access only single medium, multiple users used one single medium to transfer the multiple. If for example you have a class in that 60 students are there, we have only one single access point in that particular class. Every student will access different websites. In this case, how we have only one single medium, that means one access point, that means we are using radio transmission from your device to your access point. From access point to we are using only single medium, we are taking the only one cable from one access point to your internet through internet ISP. The same way other colleges, other schools, and other users also using same thing, and they will transfer the data to the your ISP cable. At the end, ISP to the international ISP, in that case also it is having only one single medium. It has to transfer the lakhs of information, lakhs of packets and lakhs of user information to transfer to the particular server or particular databases. So how we are getting the transformation done without any issues, without any collisions, that we are going to discuss today with the help of multiple access protocol. Okay, in data link protocol, can you hear me, ma? Am I audible, and can you see my screen properly any without any issues? Please respond on the chat box. Can you hear me properly? Is there any lag? Okay, good. Okay, okay. Today we are going to discuss about the two things. In data link layer, we have two things. First, data link control and multiple access resolution. We have seen here this data link control using all the protocols, stop and wait, and automatic repeat request, go back in ARQ, all the protocols we have seen in the last classes. Today we are going to discuss about multiple access resolution protocols in this chapter. Our data link layer has two things. First, data link control and multiple access control. That means if the more than one user is accessing the same medium or same link, in that case how it is going to understand is that a link is free or it is busy, how it is going to send the packets from that particular link to accurate information transformation. How we are going to do that, we are going to see in this chapter, in this class. What is the need actually multiple access in the real world? You do not have only one user. It is a network. Internet is nothing but a network of networks. Okay, and your multiple access is responsible for resolving access to the shared media. That means if one particular person, if you are using your only dedicated media, if it is dedicated media, we do not have any issues. If you are using in your home or in your college, from you to your friend, if you are having dedicated media or dedicated cable, in that case we do not have any issues. But in real world it would not be like that. Your channel is not dedicated, it is shared by among the lots of peoples. Right now we are seeing in the act fiber or Telangana government, they are giving free of cost, free of thing, 1 hour or 2 hours access to the Wi-Fi channels, Wi-Fi things. If it in that case, how many will access that particular thing? how to transfer. Whenever we are transferring the things, how many people are accessing that particular single medium to transfer the access point, that particular thing. How it is possible? Is there any collision is happening? No collision is happening. Every time whenever I am transferring the data, it is going very well to the outside receiver or the particular server. How it is possible? With the help of this multiple access resolution protocols. Because of these multiple access resolution protocols, we are able to send properly without any collisions. If the channel is dedicated, then there is no need of multiple access supply. If it is channel is dedicated, that means if you are using in your home with your laptop to your computer with the same cable, one cable, if you are transferring that laptop to your system, or your mobile to your system, in that case, if you are using Bluetooth, in that case we do not have any multiple access sublayer kind of concept in that particular. But if we are using shared medium, if we are user sharing, in that case we need to have this particular sublayer would be aware, would be there in your data link layer to serve us better. Okay, when nodes or stations are connected to the user with common link called multi-point link or broadcast link. Okay, if the nodes or stations are connected with the common link, that is multi-point link or broadcast link, we need our multiple access resolution protocols. Otherwise it would be, we are calling this as multiple access resolution protocol. How we are going to utilize this particular thing, what are the things are there available in that particular multiple access resolution protocol, that we are going to see now. First of all, multiple access resolution protocols are again categorized into three things: random access protocol, controlled access protocol, channelization protocol. Random access protocol, controlled access protocol, and channelization. Multiple access protocols are again divided into three things: random access, controlled access, channelization. In random access, we have four protocols: ALOHA, CSMA, CSMA CD, CSMA CA. Okay, carrier sense multiple access collision detection, collision avoidance. Okay, CSMA, carrier sense multiple access, ALOHA. These are the random access protocols. By the name itself, random access means they are randomly, it will they will access that particular link and they will send through the network. Okay, controlled access, reservation, polling, token passing. These are the three protocols: reservation, polling, and token passing of your controlled access protocols. Channelization protocols: FDMA, TDMA, CDMA, that we are going to discuss in the later sessions. Okay, channelization protocols. And today we are going to discuss first thing, random access protocols. Okay, today we are going to discuss about random access protocols, ALOHA and other protocols. In ALOHA only, we are going to discuss only ALOHA protocol. That is a deeper version of your thing. That is the first protocol in your random access protocol. Okay, multiple access protocols means it is going to access only single link, that is either a broadcast link or multi-point link. In that, it is going to access it is going to have the access on your link. Is that particular link is busy, or is that it is going to check is that particular cable is ready to transfer, or it is already used by others. With that information, we are going to send the packets without any issues. Okay, okay, today we are going to discuss about ALOHA, random access protocols. This method is also called as contention method. What happens if the random access protocol? Today we are going to discuss about random access protocols. In this method, it is also called as contention method. Contention method, there is no scheduled time for the station transmit. Random access, the name itself, it is saying that we are going to send without any particular time. That means we do not have any scheduled time for transmission of that particular packets. Whenever I have the packets, I will transfer. In your network, if you have 100 people also, whenever they want to transfer the things, They will, in the real time also the same thing will happen. Yes or no? Whenever they are, what does dedicated channel means? Dedicated channel means a channel between the access point to the user, or two users are using one thing. Channel is nothing but your link between two devices. If you are using TV, okay, your remote and TV are the dedicated ones. Okay, your TV and your remote, okay, your AC remote and your AC. Okay, whenever you are utilizing two mobiles, to transfer the Bluetooth, that are the dedicated channels. Okay, dedicated channel means for that purpose only they have generated that particular, we have generated that particular dedicated channel. For never, we cannot utilize that particular channel for anything else. Okay, that particular purpose only, this particular purpose only, that particular users only. Whenever I'm saying these particular users only we are going to utilize, no one can other can interfere in that particular, no user can interfere into that particular. It can directly only that particular peoples can access that particular channel, and that particular devices can transfer the information on the particular time. Okay, after diffusing that particular thing, we cannot utilize that particular thing, no one can other you can utilize. The dedicated means that particular people only. If you are utilizing your home computer and your systems, in that case it is the thing. Okay, now this method is also random access. Today we are seeing random access protocol. This is a contention method. In this we do not have any scheduled time to send. Whenever you require, you will send the, whenever you have the data packets with you, you will transmit the through the medium. Okay, transmission is random among the stations. Okay, randomly, that means if you are 60 in your class, you will randomly send the messages to your friends and your parents and your relatives through that particular channel. Okay, you are using same channel, but randomly you are transferring the information to the server. As well as if you are using a tessellator kind of thing, even, yeah, in that case also one person will do the programs in morning time, one person will do in the different time, and some other person will access the same things in the different time. That is the randomly they are going to access the services from that particular service. So this is called as random access. There are no rule to specify which station should send next. And if you are using 60 students, all are using tessellator or kmitonline.com, okay, there is no rule, all are using same thing. What will happen, one thing, my server is one, yes or no? My KMIT online server would be located in the cloud, that is the AWS cloud, in Amazon Web Services. In that particular cloud, I have the service. Okay, that services is through connected through a cable. That is not a normal link only. When I am saying that is connected through a link only, it will have only single link. But whenever the 200 or 500 students or those all over my college are accessing the same server whenever they require, that means whenever I start the particular quiz, they will access the things according to after 5 minutes, 10 minutes gap, they will, or 2 minutes gap, they are going to access the services of my kmitonline.com in their accordingly they will access. Okay, and there may be a chance of we are using only single medium. If you are using same hostel, if you are using, you are sitting in the same class, in that case you are using same medium, same Wi-Fi device, same radio transmission you are using. Okay, and there may be a chance of collision one, and there is no rule to specify which packet has to go first and which packet has to go next. Everyone they will write the code and they will click on the save button and they will submit the particular code to the server. Okay, there is no specific in the random access protocol, there is no rule to that which one has to send first and which one has to send next. There is no rule in this particular. Station competes with one another to access the medium. We have only single medium, but in the random access it is going to compete with each other one another to access the medium. We have only one medium in Wi-Fi networks, only one medium, and it can have give me a minute, ma. The stations which are using, that means the 60 students mobile devices will uh, compete each other. Okay, compete each other to access that particular medium. We are using one single device, one Wi-Fi device to transfer the data from here to your server. Okay, so in the random access protocol we are competing each other. That means one particular person is going to send 10 or 20 packets at a time, so there may be a chance of collision in that particular. How to access all the things we are seeing. For each instance, the station has data to set. That means whenever you are, for each instance, that means if you are having 4 or 5 programs or 4 or 5 different quizzes in your catalog, in that time, every instance, that means first time, whenever you are submitting that particular program, first program or first quiz, in that case it will have the data to send each instance. Like that, if you have the 60 students in your class, for each student has the data to transfer, each student and each instance means whenever you will have the same student, but for the DCN he will have the one instance, and other class, that means DS or some other class, CDS, whatever class you have, for each class you will have different instances. For that particular class you are going to participate in the quiz, and in that particular class you are going to participate in the programming in that particular class. For each student, for each instance, the station has the data to send the different data. How in the particular thing you are going to submit some other answers to my quiz, and in the particular instance, for each instance, each student will have different options to send to the data to the set. Okay, it uses the procedure. My random access protocol uses a procedure to define by the protocol to make the decision on whether to send the data or not. On that particular, whenever I'm submitting, whenever I'm clicking on that particular thing, my random access protocols must define the procedure, how to send, when to send, uh, whether I have to send or not. We have to wait some more time to transfer the data to the server, and this kind of things would be defined and decided by your protocol. That means your set of instruction, your contract would be done by your random access protocol. Okay, it depends on the state of medium. Okay, obviously it is going to, whenever you are trying to submit the data, whenever you are trying to submit the data, whenever you are trying to send the data, it depends. The random access protocols, first they will check the state of the medium. Okay, whether that particular link is free or busy. Okay, it depends on the if it is free, in any case, anytime you can send properly without any issues, you can send the data. But if it is busy, in that time what would have to be done, that is nothing but we are going to learn in these protocols, random access protocols. Okay, in this, no station is superior to another. Yes or no? These are the three things. No station is superior to another. No station is assigned control over another. No station permits or does not permit other stations to send. You have your mobile, you are going to send a message, Skype message or WhatsApp message to the other. Are is there any other device which is controlling your mobile? No. In real world we are not controlling, and you in your random access protocol also we do not have any thing like that superior. That means my mobile is not controlled by any other devices. My WhatsApp application is not controlled by any other device. Not no station is assigned control over another. Like this I do not have any. All the application, all the devices are independently, they are working. They are not having any control to send saying that you have to send that particular thing. You cannot send right now, the medium is busy, like kind of things we do not have in that. But no station permits or does not permit other station to send. We are not asking any information, we are not asking any permission from the other station to send the data or receive the data. We are just sending. There may be a chance of access conflict collision. Whenever I request, I'm sending the data throughout the link, but there may be a chance of access conflict collision. That means whenever I'm accessing the link already busy with the other users. In that case what happens, I am sending one packet or three or four packets at a time, okay, with the user using go back n protocol. In that case what happens, other person also have sent the four frames at that time, okay. There may be a chance of collision of that particular two packets, and there may be a chance of discard that particular thing. Why? If the two packets are combined, or that particular packets are come across the particular thing, the packet is nothing but the zeros and ones, yes or no. Whenever I am combined in that particular thing, my data will be modified and it would be changed. The medium is going to send the zeros and ones, but whenever I am transmitting both the things in one time, that means my starting flag and ending flag, meanwhile some other data has come and it has touched that particular another packet. In that case there may be a chance of collision of your packets, okay, when you are transferring from one place to another. Okay, to avoid these collisions, to avoid these collisions, we are going to have the in random access protocols, we are going to have the four protocols that are ALOHA, CSMA, carrier sense multiple access, carrier sense multiple access collision detection, collision avoidance, CDCA, collision detection, collision avoidance. These are the four protocols we are going to discuss in the random access. Okay. First, today we are going to discuss about ALOHA. First protocol is ALOHA. Actually it was designed for a wireless radio LAN. Wireless radio means your wi-fi, okay, radio transmission LAN, wireless radio LAN, local area networks, but it can be used for any shared media. It was designed in the taking care of wireless radio LAN, but this particular protocol can be used for any shared medium, okay. That is the one thing. There are two types of methods in ALOHA. Okay, first one is pure ALOHA, and second one is slotted ALOHA. Okay, we are going to see these two methods of your ALOHA, how to overcome this collision of the data packets in your shared medium. First thing, pure ALOHA. It is a simple protocol. The idea is that each station sends a frame whenever it has a frame to send. Okay, there is no any kind of thing. This is a simple protocol, simple contract between the sender and receiver with the shared medium. The idea is to each station sends a frame whenever it has a frame to send. If I have a frame, I will send properly. Okay, if I have 60 students in your class have frames or data to transfer, in that kind, without any hesitation, they can send the 60 frames or 600 frames, not a problem. It is going to, whenever it has the frame, it is going to send the in pure Aloha. Only one channel to share in this particular thing. Only one channel is there to share that particular. That means you have only one Wi-Fi access point. From that particular channel only you are going to transfer. There is no possible. There is a possibility. There is a possibility of collision. If obviously if the 660 students are transferring through the only one single device access point, in that case there must be a possibility of collision. How it is going to be happen, that particular collision we are going to see diagrammatically in the next slide. You see here I have 4 stations. I am using same medium. Okay, shared medium I am going to use for transferring the data from station 1 to some other station, or the server 1, secondary station, or the server 1. Okay, over a period of time I'm using only one shared medium and 4 different stations. Okay, over a period of time I'm transferring the data. My station 1 is transferring the frame 1.1 and 1.2, station 2 transferring 2.1 and 2.2, and station 3 is transferring 3.1 and 3.2. Okay, for the sake of understanding, I have wrote that particular thing frame 1.11. There would be compulsory sequence numbers for that particular frames, and the station number, addresses, all the things would be there according to your data link protocols, control flow control and error control protocols. Okay, according to that would be, for the sake of understanding, I have kept it as a 3.1 3.2 for from the station 3, and the station 4 4.1 and 4.2. Over the time period, that means in the first station, after 10 seconds or 20 seconds gap, it has sending 1.1 and 1.2, and over the period of time, that means you can see here, and the dotted line, that is the time. Okay, whenever these particular 4 stations are sending, whenever they have the data frames process that particular frame, they are going to send that particular thing. What happened whenever that particular things happen, these all the things are going through my single medium. There are two places the collision was occurred here you can see in the black shadow is there. Okay, black shadow is there in this particular thing, frame 1.0, 2.1, 3.1 and 4.1. In this particular time, these four frames have collided each other. These are discarded. Okay, in the next time period, and frame 2.0 and 4.2 also collision, the collision in that particular collision duration, my here collision duration, you can see the collision duration also. In that particular duration, my 2 frames, frame 2.2 and frame 4.2, these are collided, and my data is discarded. At the end, I have received it a sound and accurate frames are only 2. If I have sent total 8 frames, but at the receiver end I have received only 2 frames, that are frame number 1.1 and frame number 3.2. Frame number 1.1 and 3.2, only 2 frames I have received at the receiver end. All the others, I should get the negative acknowledgement, or after some timeout period I have to resend all the frames through your station must to send the frames to the receiver. Okay, collision, where the collision there may be a chance of, we are using same thing. Frame is nothing but your 100001 10001, like this you will have the binary bits. Okay, binary bits you're going. If this particular thing in the shared medium, if you are sending same bits, what will happen? Definitely it is going to collide each other, and it is going to, your data would be collapsed. Yes or no? Is it clear? Any doubts in this particular thing? Okay, we are going with pure aloha. Your pure aloha relies on acknowledgement. That means that it is going to depend on the acknowledgement. If the acknowledgement does not arrive after timeout period, it will have every time your every device, your sender will have the timeout period. That means whenever it is sending that particular packet, it is going to have the timeout period. It has the timer. It is going to start a timer whenever that particular timeout period is completed. The station assumes that the frame does not destroyed, or destroyed the frame as destroyed, so it has to it is going to resend that particular frame to the receiver. Okay, automatically it is going to have the timer would be activated. After a timer period, it is not going to, if it is not finding any acknowledgement with for the particular frame, it is going to resend that particular frame again. Okay, a collision involves two or more stations. Okay, here we have seen that collision means if you are using only single station in the shared medium, in that case there is no chance of collision. Okay, collision occurred means it is going to the shared medium on that particular time, on that particular point of time, it is going to use the shared medium is going to used by two or more station, then only collision would happen. Otherwise it is not going to. If you are having only in your house or in your college, in your class, if you are using wi-fi only, there is only one student, there is no chance of having happening of collision. But if the students are more than two, if the students are more than two, then only that there may be a chance of having collision. Okay, if there is a stations try to resend their frame, what happened, it has already in this example. Okay, all the things has that means 6 frames does not reach at the receiver end. What it will do after timeout period, my all the frames, station 1 to all the stations, station 2 3 4, all stations will resend the frames that 1.2 2.1 3.1 4.1 2.2 4.2. These frames it has to resend that particular. If they resend after timeout time, again there may be a chance of having collision. Okay. Okay, that's the reason pure aloha dictates that when the timeout period passes each station, okay, whenever the timeout period has completed, after that you have to wait a random amount of time before resending that particular device. Why? Otherwise what will happen, all the timers, whenever the timeout starts, that particular in pure aloha it is going to have only random amount of time it is going to wait, and it is going to resend that particular frames after this particular time. Okay, the time is called as back of time, TB. The time is called as TB. Okay, now we are going to see the algorithm, how this pure aloha will work algorithmically, diagrammatically. We are going to see how this particular thing will happen in this particular thing. Okay, shared medium. Okay, first algorithmically we are seeing. First of all, I have a station 1. Station 1, I have number of frames in my hand. Okay, first I will start my algorithm. First I will check what is my number of attempts for that particular frame. I have a frame 1.1. I will show with at its place. I have a frame called 1.1. Okay, I will first start. While starting, my number of attempts are, I haven't sent till now. This is the first fresh frame, so my attempt number is, I will consider as 0. Okay, attempt numbers, I am going to consider it as 0. Okay, send the frame. Next, after that, after completion of this year, you first of all, I am considering my attempt number is k is equal to 0, and after that I am going to send the frame. Okay, after sending that, I am going to timeout wait for timeout time. Okay, I will wait until my timeout time is nothing but 2 into 2 to the 2p. 2, what is 2p? Maximum propagation time, that we are going to discuss. Okay, maximum propagation time. Okay, 2 into 2 to 2p maximum. What is maximum propagation time? Okay, wait a while. Okay, after my whiteout time, if meanwhile, if I get the acknowledgement, if I get the proper acknowledgement, if I get the proper acknowledgement, that case I am saying that my frame sent successfully, I need not to do anything else. Okay, just if I did get the acknowledgement, it is the normal simply sending one single frame from sender to receiver using shared medium. If the acknowledgement not received, what I have to do? I have to increase my number of attempts. After the timeout period, automatically I have to resend that particular thing. Okay, and first of all, I will increase my k value. K is nothing but my number of attempts to sending that particular thing. My k value, first time it is my k value is 0. Now my k value is k plus 1. That is my k value is now k 1, not the k. My k value is 1. Now after this, I have to check in the pure aloha. It is going to one another contract, one is thing is there. It has to check if the continuously it is sending for or 10 times or 15 times. Okay, what happens in the pure aloha, it will stop that particular process. Okay, after some 15 attempts, it is going to stop that particular thing. It will wait for 10 or 5 minutes. Okay, after that it is going to resend that particular thing. Okay, that is nothing but your kmax. Kmax is the after 15 attempts, it is going to usually normally most of times kmax is defined to 15 only. Okay, after 15 attempts, it is going to stop the resending, and it is going to wait for 5 minutes or 2 minutes, whatever the time according to that your protocol. It is going to wait some more time. After that, it is going to resend the fresh. It is going to send freshly. It is going to start the resending. Okay, that is nothing but kmax. After increasing my number of attempts k to 1, I am checking, is there my k value is 15 or not. If it is 15, I am just aborting that particular. If the k value is greater than kmax, that means if the k value is more than 15, in that case I am going to abort this machine, and I am going to wait for some more time, and after that I will start freshly. I will start for start sending that particular packet after some time. Why? My shared medium is busy. That's the reason I will abort the same. If the k value is less than that particular k max, in that cases, in this condition, it is going to a take a random number. It is going to take a random number, take a random number between random number r is nothing but your random number. It is going to take a random number r between 0 to 2 to the power of k minus 1. Here you can see it is going to take k is equal to k value is 1. So 0 to 2 to the power of 1 minus 1, that is 2 minus 1 is equal to 1. 0 to 1, it is going to take one random number, that is 0 to 1, and it is going to wait for that much time. For that is the blocking time, waiting time. We are going to wait for that particular time. Back of time is nothing but TB is nothing but back of time, random number either 0 or 1. Okay, 0 and 1, between the 0 and 1, if you are taking 1.2 or 1.3, r into 1.3 into t to the power propagation time, maximum propagation time it is going to wait. After waiting this particular propagation time, after this waiting propagation time, it is going to resend that particular frame to the receiver. Okay, it is directly redirecting to the send the frame channel here. Okay, are you clear in this? Do you have any uh, things? We are anyhow we are discussing what is TP, TR, TFR, all things we are going to discuss, but this is a clear cut and out frame thing of your pure Aloha protocol. First it will go start the transmission of that particular thing. First it will set the number of atoms k value as 0, number of atoms k value as 0. After that it is going to send the message. After sending that particular message, it is going to wait for timeout time. It is going to wait for timeout time. That is the timer. It is already on the timer, and it is going to wait for timer. What is timeout time? 2 into maximum propagation time. 2 into maximum propagation time. It is going to wait. In this time meanwhile, if it is getting the acknowledgement successfully, that packet is sent to that particular place, so I do not have to do anything. I will come out of that particular algorithm. Okay, if I did not receive any acknowledgement, or the timer period is completed, in that case I am going to increase my k value, a number of attempts I am going to increase that particular thing. And here one thing is there, it is going to resend till the 15 times only, not more than 15 times. The k value is k max value is 15. After 15 values, it is going to stop the process for some time. After that it is going to restart the process freshly. Okay, k max value is normally set as 15. Okay, now here I am checking the k value. Will it the k value is greater than particular k max? If the greater than k max, in that case I am directly aborting that mission. I am not doing anything. I am coming out of that particular algorithm. Okay, if the k value is less than k max, in that case I am going to choose a random number between 0 and 2 to the power of k minus 1. Okay, 0 to that particular, that random number I am going to wait for that random number into t to the propagation time, maximum propagation time. And it is going to propagation time or maximum propagation time or average transmission time of a frame. Either both of the things I can take, whatever I need. Okay, TB, backup time, is equal to r into maximum propagation time, or r into average transmission time for a frame. Okay, one frame, what is the time it taking to transfer the one frame between the two what you say, two different sender and receiver. That means in the particular link, if I have two widest means lengthiest devices. If I have two lengthiest devices in but that particular uh, shared medium, how much time, average time it is going to take transmit the data from one that place to another place is nothing but your average transmission time of a frame. If the same thing, how much time it is taking to send one frame from that particular wide devices is nothing but maximum propagation time between that particular thing. Okay, whenever I am taking this waiting time, I will wait for some that time. After completion of that waiting time, I am going to resend the data to the receiver. Okay, this is the pure Aloha protocol in your uh, what do you say multiple access resolution protocols. Pure Aloha protocol, which is the random access protocol. Are you clear, ma? Are you there? No one is responding to my question. Over one or two students are there in my meeting room. Okay, this is the normal procedure for pure Aloha. Okay, what is the throughput and what the things TP and all the things we are going to discuss in the next slides. Okay, propagation delay TP. Propagation delay TP is nothing but time taking to send a frame between the two most widely separated stations. That means in the classroom, if the uh, you are having the Wi-Fi device, access device, one person is sitting in the corner. Okay, if it is my device is capable of having 10 meters 10 meters radius, in that case my widely separated stations are sit at the 20-meter distance. That means my from the my center of that my access point, one person is sitting in the right side. Okay, 10-meter distance, another person is sitting on the 10-meter distance separately in the left side. Okay, what is the distance between these two separated stations? 20 meters of that particular thing. So what is the time taking process to send that my left side to right side stations is nothing but my propagation delay, that is TP. Propagation delay, time taking to send a frame between two most widely separated station, is nothing but TP, that we are going to taking as the T. What is the time out period? What is the time out period I am taking here 2 into 2 to TP. That means propagation delay into 2 times. Twice of the propagation delay I am taking as the timeout period. Why? If one station, if the my station is in the radius, in the particular radius also, it should not be take the, if it is 20 meters lengthy, if the two devices not my devices must not be more than that 20 meters delay, that must not be more than that particular 20 meters. If I am trying to send I am trying to wait that particular thing more than that 40 meters delay time, 40-meter delay time, that would be waste of time. So I am taking it considering as, if it is the 20-meter propagation delay, I'm considering that into 2. I will wait for the 2 times of that particular propagation delay. Okay, back of time is nothing but your random, first I am taking a random number r into propagation delay TP, into propagation delay, are the here we have two things: maximum propagation delay, maximum propagation delay, average transmission time for a frame. Average time is nothing but, if I am sending 5 frames, what is the average time to transfer the from one place to another place? That is the average transmission. Either I am going to take the maximum or the average propagation delay between the two senders. Kmax is usually chosen as 15, as we have discussed in the algorithm also. That is Kmax, that is the number of attempts to be transmitted, how many attempts we are taking. Here Kmax is normally fixed to 50. Okay, vulnerable time. What is the vulnerable time? That means there is a time to happening of that particular collision. Okay, time to find out the collision time. Wait time, sir. Okay, give me a minute. Here, wait time. Here I am considering wait time. Wait time is nothing but, I am going to take the time, random time. First of all, I will take the a random amount, random number. First of all, random number is nothing but you can take any number between 0 to 2 to the power of k minus 1. This is the simple thing. First of all, you can choose any time, that is number 1.2, 1.3, 1.4. According to that, you are going to take the particular thing 0 to 2 to the power of k minus 1. If it is 1, 0 to 1, 0 and 1, between 1 I will choose one number between that particular thing, that is 1.4. If 1.4, you can take it as. If it is 2, in that case 4 minus 1, 0 to 3, 0 to 3 I have to take the random thing. Okay, I will wait until that random time into random time into maximum propagation time. Waiting time is nothing but random number into maximum propagation time or average transmission time. That particular time I am going to wait for retransmission. Okay, I am going to wait for retransmission. First of all, I will choose a number, random number between 0 to some number, that is 2 to the power of k minus 1. Okay, k is nothing but your number of attempts. If the number of attempts are increasing, so my random number will be automatically increase. Okay, if the number is 5, in that case you are going to have 0 to 31. In that case, what will happen, I may get the 16 or 7. If the my k value is less, in that case it is going to have the small amount of time that I'm going to wait. Okay, if it is 16, 16 into maximum propagation time or average transmission time, I'm going to wait for some time, and I am going to, after waiting that particular time, I'm going to send the frame. What we in meanwhile, what happens, the either my media or medium will be freed, or it is busy. Either it is busy or it is free. That we are going to discuss. This is the first protocol which were developed in the olden days. Okay, this is going to, my Aloha protocol is going to, sir, what okay, that is the thing about waiting time. I am going to wait some more time to resend the, why, I have already sent that particular frame, but the frame has not reached the destination because of my medium is busy. So next time whatever I'm sending, I'm going to wait for some time, that is the propagation random time, random number into propagation, maximum propagation time. I'm going to wait. That is nothing but your waiting time of resending the data. Okay, is it clear, ma? Waiting time 446. Back of time, back of time. Back of time is nothing but R into TP. That is the waiting time is nothing but we call it as back of time or waiting time are both the same. Okay, is it clear, ma? 546. Any doubt? Okay, good. Here you say, you can see vulnerable time. How you are going to consider vulnerable time? The is the vulnerable time is the length of time in which there is a possibility of collision. There is a possibility of collision. There is a possibility of collision t into t plus. That means whenever I'm saying there is a possibility of collision is one first of all, one minimum transmission time. That means minimum transmission time is TFR, frame transmission time. Okay, average transmission time I'm taking as TFR here. Okay, but here one if whenever I am sending one frame, my vulnerable time is 2 into the double of the one transmission time in this particular thing. Okay, that is the twice of my average transmission time of one frame. Okay, vulnerable time. There may be a chance of having issue Okay, vulnerable time is nothing but that is a collision time. There may be chance, a possibility of collision is the time of one process transfer to another. That means here you take that particular thing. One example, I am sending one packet one, frame one to sender to receiver. Here frame one. Okay, how much time it will take to from here to here? It will take only fr. Okay, fr, tfr. Okay, it is going to take the tfr. How then, what is the chance of that particular thing? Either if you are sending, that is the 2 into fr time. That means the 2, not more than, if that particular thing is the 2 into twice of that particular average propagation time. If it is taking, that means it is compulsory, it is the avoidance. Your data is collapsed between the two things, not more than. The vulnerable time should not be more than that. And it is not, whenever we are considering vulnerable time, that is the maximum vulnerable time we are going to take. It is not the minimum time. If I am taking tfr, there is no standardized thing in that particular thing. That is the maximum. Okay, whenever I am taking 2 fr, that means of this is the equal to your propagation time. To propagation, it is not waiting time, it is going to be the propagation time. So the vulnerable time is 2 into the minimum average transmission time of your thing. Okay, 2 into tfr. Okay, throughput. What is the throughput? Throughput of ALOHA is S equal to G into e power minus 2G. Okay, what is G here? My throughput is considered as S. Throughput is S. G is what? What is G? G is nothing but your load. Load is nothing. Average transmissions attempts. Average number of transmissions attempts per that particular x time, x seconds. Okay, if I am taking the 5 seconds time, how many transmissions would be happened for the that device? The how many transmission it can transmit if it is the if it is free in the 5 seconds, that is nothing but G. So my ALOHA S equal to G into 2 to the power of minus 2G. What is the S max? That is, what is the throughput? What is the maximum throughput of your pure ALOHA is 0.184 when the Z is equal to 1 by 2. Okay, that is the S max is 0.8184. Okay, then that means whenever I am transmitting the data using pure ALOHA in the shared media, there may be a chance of only 18.4 percentage of frames out of 100%, 100 frames. 18.4% of 18.4 frames would be reach destination properly, not more than that. Frames would be reached at the receiver end with the help of, if I am using pure ALOHA. Is it clear, ma? Throughput. Any doubts in this? Okay, I'm going with slotted ALOHA. To overcome this, okay, to overcome this, we are going to have slotted ALOHA. In this, what I will do, I simply make the time into slots. That means 9 o'clock to 9:05, 9:05 to 9:10, 9:10 to, like this. I will cut my time into 5 seconds, or 1 minute, or 30 seconds. I am going to cut my time from starting to end. How much it is the every time whenever the station has sent, whenever station has to send, it has to wait that until that particular starting time of my slot. In that particular slot time only I can send the frame. Middle time, in that particular other times I am not going to send. In if I use this slotted aloha, what happens here, you see, in the pure aloha, the thing is happening. If the beginning and the b frame, if the frame wait for 2 more seconds, there may be a not happening of uh, collision. Okay, if the c frame starts at the this end point, okay, if the my time is sliced, and if I have the slots, in that case my c frame would start after this particular time slot only. There must be, do not have any collision with the help of, if I have the slotted. Otherwise what happened, in the this particular 1-2 seconds gap only, I have the collision occurred with the 3 frames. If I ask them to start at the beginning of this particular time only, in that case what happens, if it is started in this particular beginning, it is not going to drag till this particular thing. Okay, if I ask this c frame also, that particular frame also, to wait for the end of that slot, in that case also there must be my throughput would be increased to the twice of that particular thing. Why? It is the by because of that particular thing only I am not able to properly send to my messages to the frame. Here you, in the first frame, in the first pure aloha, I could able to send only 2 frames to the receiver. But here you can see, I can send, because of this slots time slot, I can send 4 frames without any collision to the thing. So my throughput of my slotted aloha is double in case of pure aloha. Is it clear, ma? My throughput of slotted aloha is increased double in slotted aloha over the pure aloha. Okay, collision duration is this particular thing only. Okay, in this particular thing only 1 frame is going through here in this particular time. So I do not have any collision occurrences. So my 4 frames have reached to the destination properly without any issues. Okay, here throughput of your slotted aloha, is equal to g into e power hyphen g. Here I am not taking minus 2g. Okay, only g. That's the reason S max is doubled, 0.368, 0.368, if whenever g equal to 1, it makes the how throughput is double. Okay, wait. If here you see, the plan is nothing but, when it is the vulnerable time. What is the vulnerable time? The time taken for having the issue collision, the time taken to having the issue. Okay, what is the vulnerable time if we are taking here? I do not have any perfect plan for that particular pure aloha. Whenever I need, I can send the data. Okay, in this case what happened, in my slotted aloha, my time is divided into that particular thing. Okay, my time is divided into that particular, so there is no chances that overcoming that particular thing into next time. Okay, my overcoming that particular thing, whenever I am sending the frame, I cannot send my frame after that particular time slot. That whenever the time slot is starting, then only I can send. Okay, after completion of that after starting that particular time slot, I'm not going to send any means. I have to wait until the next time slot starting time. Okay, in this particular thing, pure slotted aloha, I have to wait I have to wait. I have to wait until the next thing. So what happened? There is the uh, I'm increased my rate of frames at a time. Okay, how my rate of frames I am increased, how the, because just because of time slots. So I will modify my protocol according to that rule. Whenever the rule is saying that I have to start that particular, the rate of transmission is also increased from 1 by 2 to the rate whatever the I'm transferring. Here you see the load of that particular thing, the average transmission attempts per 5 seconds. I will increase it to 1 by 2 to 1, 1 by 2 to 1, z into 1 by 2. Here I am taking as the 1 by 2, 1 by 2 off of the particular load only I am taking. But here I have the less load. Why? Half of the load only, less load I can send. Why? With that particular time slot only I can send. After that I have to wait for next for 5 minutes or 10 seconds, 10 minutes, 5 minutes for the next time slot. Till the next time slot starts I have to wait. Ideally I do not have any other works. Okay, in the pure aloha it has to have the particular time only. That the reason it is going to have the thing. Okay, g is equal to 1 into e to the power of minus 1. That's the reason it is going to have the 36.8 percentage of throughput. It is going to give the, so slot is the half of the time. Yes, f for sir. Yes, correct. My throughput is half the time, increased to double in case of slotted Aroha, because of only one modification, simple modification I have done. First of all, whenever I get the frame I will send, but in the pure Aloha. But here I have the only one condition: if the time slot starts then only I am going to send, otherwise I am not going to send. I have to wait for that particular time whenever the slot starts. I have, if the my frame has got here also I have to wait till here. So that if here you see in the slat 4, if in my fourth station or the fourth station get the frame here itself, here itself. Okay, even here in the middle of the fourth slot, even it is not going to send. So it has to wait the time till the starting of the next slot. So I'm avoiding the collision here. Okay, my third station got the frame at the middle, but it cannot send that on the particular uh, time slot, fifth time slot. I have to wait the starting of the next time slot. So here also I have avoided. Okay, here like this. Here you can see after frame 1.1.1, if I got the either I got the second station or third station, middle of the time slot 1, in the both the cases I have uh, moved my frames to the next time slot. So I did not get the any collision in between this particular thing. Okay, but some of the collisions must happen because of at the same time, exact time, these two stations are started at the starting of the slot 2. In this case I could not do anything in my slotted hello. Okay, by the next protocols we are going to overcome these things also, in that carrier sense multiple access and carrier sense multiple collision detection, collision avoidance kind of things. We are going to have these particular things in that particular protocols. This is all about your Aloha pure and slotted Aloha. Any doubts, ma? Fifth slide. Fifth slide. Random access protocol. Is it this one? Okay. Okay, I will activate the quiz. Please, whatever we have discussed, that only we are going to have in the quiz. Please, you have 2 times of attention. You can attempt 2 times. Please check the options clearly. After that, only you are going to submit. Otherwise, what will happen? There may be a chance of having the same things to take for your unit test also. You will lose unnecessarily. You will lose the marks. Okay, so that's the reason you please think before you are submitting your answers. Not for the sake of attendance you submit the question quiz. It will help you read 1 or 2 times. It will help you in the exams as well as your computer network society also.